this here. Okay. Excuse me. All right. So, I don't think I needed to go through for you guys the basic conversions. Just know that if I'm going from micrograms to milligrams or grams to milligrams, you do not round basic unit to unit conversions. Do not round those. Please do not round those. You will probably need to, or you will likely need to round when you go from pounds to kilograms or kilograms to pounds. You may need to round, and then you would just follow the rounding rules. Numbers greater than 1, round to nearest 10th. Numbers less than 1, round to nearest 100th, so on and so forth. All right, but let's get into some questions that I know over the years have been challenging for this class. I'll definitely say like this first one here or this question number 11 about the dopamine infusion. Because this is a weight-based calculation, a lot of times students get hung up on how to answer this question, but you've done a question very similar to this with the heparin protocol question. So let me show you how we would do this. I'm going to show you using dimensional analysis, and I'll also show you just kind of how to figure your way through it. If you do this a slightly different way, or if you set up your dimensional analysis a different way, as long as you're getting the same answer that I'm getting, you're doing it the right way. Okay. Just letting you know that right off the bat. If you set it up slightly differently or differently than I do, or it looks completely different, but you're getting the right answer, you're doing it right. Okay. So don't, you don't have to worry about like, oh, did I, why is he doing it this way? It's just the way my mind works. Your mind might be, doing this just a little bit differently, but we're all, as long as we're getting to the same answer, I think we're doing it the right way. So this question says, we want to know what rate should the nurse begin the infusion? Now you might be sitting there going like, well, what am I looking for here? Am I looking for drops per minute? Am I looking for micrograms per minute? Or am I looking for milliliters per hour? If you know nothing else, as far as when they mention an infusion, that should be your default, that you are looking for milliliters per hour. However you want to dice it, you're looking for milliliters per hour because it tells you you're looking for an infusion. Okay. So that would be my default. The other thing I'd be looking for is if I was questioning, is it drops per minute? They would have given me some sort of indication of like a drop factor or something. There is no drop factor listed, so we don't need to worry about that. All right. So we have a couple pieces of information here. We have a patient weight, 70 kilograms. And then we have a what we're going to start it at, and it's listed at 5 micrograms per kilogram per minute. Okay. Correct. So someone asked, it wouldn't be milliliters per minute. Correct, because that's not an infusion rate. That at least not that you would use as a nurse. You're either going to be doing, it's always going to be milliliters per hour or drops per minute. Okay. It's never going to be milliliters per minute. So you need to know milliliters per hour. All right. So we have 2 pieces of information, and then we have a third piece of information. We have the IV, and the IV is 400 milligrams, 250 milliliters. Okay. So I'm going to work through this the way I see it. So the way I am going to work through a question like this is I'm going to start with the patient's weight. The reason being is there's really no reason why. I just always start with the patient first, then I kind of go through the order and then do my conversions. If you prefer to start with milliliters per hour and then do your conversions that way, perfectly fine. But I always like to start off with the patient's weight because I like to get rid of that kilograms as soon as possible. So what I'm going to do is I'm going to take my 70 kilograms. I'm going to multiply by what it's telling me to do here, which is the 5 micrograms per kilogram per minute. So what that does is it eliminates kilograms. Now you can go ahead and solve for this. You can get to 350 micrograms per minute, and then you can kind of do this in steps. I'm going to show it to you all as one long dimensional analysis. That way, all you have to do is worry about plugging in things into your calculator once through. But if you want to chop it up, you can. And if you have no other method of doing this, I just want you to know there's more than one way to kind of answer this question. Okay. Now we're at a point here where the only units I have remaining are micrograms and minutes. Okay. The problem is, I need to have similar units to compare to. We already know we're looking for milliliters per hour. So that'd probably be the first thing I would do, is just go ahead and convert minutes to hours. So notice I haven't done any calculations yet, other than telling you it's 350, but I'm going to convert minutes to hours. 60 minutes, 1 hour. Okay. So as always, the reason I have always liked to use dimensional analysis, particularly for the sciences, which includes nursing, is because we can see what we have left before we do any kind of calculations. Like if I had the hour on the top, I would already know that I was wrong, because the hour should be on the bottom. And it kind of gives you an idea of like, okay, this is where this should be written out. Okay. I'm not going to keep, arguing why I prefer to do it this way. I'm just going to show you just how I would do this. And then if you have a different way and you're getting it right, you're doing it right. So don't get hung up on how I'm doing it. Now, the next thing is I could put my conversion for milligrams to milliliter. The problem is, if you do that right now, you're in micrograms. I would highly recommend that you do the conversion of micrograms to milligrams first before you progress on to converting the milligrams to milliliters, just because a lot of times students will forget that step. And this question is a doozy of a question, which is why I decided to show it to you first, is we might as well get right into the meat of this question. I have a feeling if you see a question like this, what's going to change is, well, any of the variables can change. Patient's weight, the order, in micrograms per kilogram per minute, and then the available, but it'll probably all look very similar. So what I'm going to do next is I'm going to actually convert the micrograms to milligrams. So 1 milligram is 1,000 micrograms. Yeah, I did that right. Okay. Just making sure I was doing that right. All right. The next step is, now that I've gotten rid of micrograms, the only thing I have left here is hours and milligrams. Okay. And again, if you don't like this dimensional analysis stuff, you're hating this, but I'm just telling you, this is just a way to kind of represent. So even if you're just writing along with me, you're at least going to learn a strategy for solving a question that's like this. And then I'll tell you how I do this question without it in just a moment, without dimensional analysis. All right. So now I have milligrams per hour. I want milliliters per hour. Now I can use my available. My available is in milligrams per milliliter. So it's a way for me to convert. So I have 400 milligrams and I have 250 milliliters. So it just gives me a way to kind of convert everything. And at the end of writing all this crap, okay, I have milliliters and I have hours, which is what I'm looking for. Okay. So in my calculator, what I'm going to do is I'm going to pull up my calculator and then share it so you can see how I'm putting these numbers in, just so if you're ever wondering, like, am I doing this right? You are. Just all right. All right. So I'm going to take 70. And what I'm going to do is I'm just going to multiply all the way across the top. 70 times 5 times 60 times 250. Okay. And I'm going to get 5,250,000. Okay. Then I'm going to divide by everything that's in the bottom. I'm going to divide by 1,000. And then I'm going to divide by 400. oops, 400. And I'm going to get an answer that says 13.125, which I believe is what they have listed as the answer to the key to this problem. But you know, and I know that we don't write 13.125. What are we going to write? 13.1. We round to the nearest 10th. Okay. So let me go back to.
That's not the answer that's in the key.
Okay. Well, then I will tell you that the key is wrong and what I've written is correct.
Okay. They had 22 milliliters as the answer.
Okay. I have a feeling that whomever put this together probably just wrote down the wrong or paired the wrong question with the key. Was there anything that had that answer 22 milliliters that you saw?
Actually, if you first calculate, and I understand the infusion rate should be milliliters per hour, but if you first calculate it, like I did, first milliliters per minute, it would be 0.22. But then when we multiply it by 60, we will get like 13.1 or 2, like depending on the rounding. So
Okay.
I don't know. But it's still the wrong decimal, I guess.
Yeah,
right.
that's what threw me. That's why I was like, oh my gosh,
Yeah, like
I'm
at
really
some
wrong.
point I got 0.22, but that would be the rate per minute, not per hour.
I just want to see what they have written here. So, like you said.
Yeah, it says 22 mils.
Okay. Yeah, so I don't know what happened there, but yeah, this should be 13.1. It's even the wrong units are listed there, so. Okay. Who administered these? Professor Nanjut?
Yes, we got it as part of the information letter about nursing 240.
Okay.
So it was signed by Professor Nanjun Dapa, and I guess Connie emailed it to everyone.
Okay. All right. I'll let her know because that would be good to know. So I gotta make a note here.
I'm glad we went through this.
Well, and you can also thank Natalia because she's the one who initially brought it to my attention. And then I was like, okay, I don't know. I didn't know what question it was because I didn't have a chance to look at it before today. But then I was like, I know that this one's usually a doozy. But were you guys getting like, at least if you were calculating milliliters per hour, were you getting to 13.1?
Yes.
No, I got the 0.22.
Okay.
So.
And then you were like, oh, that's close enough. But you were doing 0.22 milliliters per minute then, right?
Yes.
Okay. All right. I'm making a note here and I'll just reach out to her, but I can tell you that the way this question is written, the answer would be 13.1 milliliters per hour, unless she wanted you to calculate drops per minute. Now, if that were the case, give me 1 second and let me think about how this would be.
Because we don't know how many drops are here.
You don't, but if you if they told you that they were using microtubing, you could assume 60 drops per minute. And so if that were the case, let me just see here. So 70 times 5 times 60 times 250. Yeah. Okay. It'd still be the same answer because it would be you would have been leaving it at 60. So yeah, I will confirm with Professor Nanju, but I do not I do know that the answer is 13.1 for the way that this is written. Because you could actually go to another 240 test where I've done the review for this, and that you could see that it's worded exactly the same way, and the answer and the key is 13.125, and that was wrong. So I will follow up with Professor Nanju, but I can give you some confidence that the correct answer is 13.1 milliliters per hour for this question.
When I worked this problem yesterday, I got the correct answer, but then was confused with the answer key. And I
Yes.
came across another problem or two that also I think had the incorrect answers. Can I just run that past you and make sure?
Yeah, let's do it.
One of them was it was number 4, so a super simple conversion, and I got 30 mLs, but the answer key says 60.
Okay, yeah, that is 30.
Okay, thank you.
Yep. Oh, I'm
And
gonna
then I
make that change right now. Go ahead.
That's okay. I think number 14. Oh no, never mind. Number 14 is correct. When you get to it, I made like notes by my questions, and I starred this one. If you could like break it down.
14, you said?
That was 14. Yes.
Okay. So 14 is, believe it or not, especially the way it's written, one of the more commonly missed questions. And it's because you want to use information that you don't need to use when you're solving for it, because there's extra information here. There's a whole bunch of things listed. So let's break it down, and then I'll show you what you need and what you don't need. That way you get it. And then of course, we always run the risk that the key is wrong. So we'll make sure we have that nuance as well. All right. So patient has congestive heart failure. They're ordered furosemide, 200 milligrams IV daily. Okay. So that's one piece of information that we need to know. The available dose is 100 milligrams IV. Great. And then it says the label reads furosemide 30 milligrams per milliliter. All right. So my question is, and this is rhetorical, you don't need to answer. What is the order and what is available? The order is 200 milligrams. The available is 30 milligrams per milliliter. What is this 100 milligrams IV? That's the same thing as saying you got 500 tablets of Tylenol. Okay. It's just telling you the total quantity. So we would actually just eliminate the, at least from our calculations, this furosemide 100 milligrams IV. So to calculate how many milliliters of this drug, you could just do, if you guys like to do order over available, we can just take our order over our available times our quantity. And then you should get that 6.7 number. $200 divided by 30. Yeah, 6.7 milliliters. It's supposed to be an ml.
Thank you. Do you have like any helpful tips for if we have a question like this, with this exact wording, how we can tell which numbers to just kind of throw out?
So I'll just say it comes with, it's just a matter of knowing that you're going to see it, and it's just a little bit of experience. So like, this is how you wanted it to look, like number 15. So, but if I told you that, Decadron is, is available in 500 milliliters, and then the drug label reads, you just need to know that, if you're talking about IV or if you're talking about an injectable, you need to know how to get to milliliters. And in order to get to milliliters, you have to know like milligrams or micrograms or units per milliliter. And so you need that information in order to make that conversion. Like if I look at this, like let's say I use the 100, what am I going to do with it? 200 milligrams divided by 100 milligrams. And then I just have then I just have two what? Like what is your, so like I said, the easiest way to answer that question is just it's nuance, and there's only going to be a handful of questions like that. And I would just, and it's most likely going to be that question where it's the, the furosemide question, and you just need to pay attention and make sure that you see that. I haven't seen where there's like a whole test of irrelevant information, but it is there, unfortunately. You see it a lot actually in reconstitution type questions where they'll give you like a label. The label says 4 grams, but you need milligrams per milliliters to solve the equation. And that's usually how I'm like, I guess that's my way of stuttering or stammering through trying to explain to you that what are you looking for next? If you're dealing with an injectable or an IV, you're looking for milliliters. So you have to have a way to convert your order to milliliters. And so that's how you kind of decipher that you don't need to know the total quantity. You don't need to know how many tablets are in the whole bottle. You just need to know what your conversion factor is. Milligrams to milliliters, tablets, or milligrams per tablet. Does that make sense?
Yes, it does. Thank you.
You're welcome. And like I said, unfortunately, like I can look at it and I'll know like, oh yeah, that you don't need to know that answer. But some of that is just by going through trial and error, putting in the equations that are there and then realizing, oh, okay, this is not a piece of the information that I needed to know. That's kind of how I did the first time I ever went through a heparin protocol. It was like, what the heck do I need to know here? Were there any other questions that were mislabeled or miskeyed? Or any other questions you have questions on?
Can we do that big heparin question?
Sure.
What number is it?
It's usually the last one.
Yeah.
So I am working with, and I am trying to work with Professor Najud on trying to change the way this is like written out, because this is just ridiculous. Actually, oh yeah, no, we're good. Actually, because I was gonna say, oh, it looks like she already changed it, because there's a lot of extra information you don't need. So just give me 1 second. I'm going to show you what I did for the 230 class. This is what I'm working towards, is trying to make this simplified. And I want to show you what it would look like if it were easy. All right. So if I was doing this question, or for this bolus question, if I was doing this to keep it simple, this is how I would try and ask the question. I would say, here's your patient, how much they weigh, here's your order or your orders in this instance, and here's what you have available. Unfortunately, the protocol is so robust, it's giving you a bunch of information that you just don't need to solve the problem. So in previous semesters, you've probably seen, if you go back and look at some of my old work, you'll see me like kind of highlight through basically steps 3 through 10, and then I cross it out. And I just say, like, you just ignore those, because those have nothing to do with anything you're doing math-wise. All you're trying to do is use the protocol to answer these two questions. What's the milliliters of the bolus? and what's the milliliter per hour for the heparin drip. Okay. And that's another thing, right? Drip, you're starting to think, oh, is it drop rate? That's just what they call it because it's moving so slow. Okay. So if I'm doing this question, I would rewrite this as this, where you have a patient weighing. So I'm just mirroring what is written above this, but you could see everything right there. I think everyone would probably be like, oh, I can answer that without, because I'm not bouncing around. I'm not looking at all over the paper. So this would be a alternative. So like if you go to, you might want to rename this when you download it because it's going to be named the same thing as what you guys have. I'll try and remember to rename this so you have actually I'll do it right now. That way you are not I just turned it to 240 review. That way, hopefully it'll save it as that instead of what was previously written there. But anyways, so this would be the simplified version of what's written in all of this. Okay. But we have this here. Let's work through this. So a couple of things I always tell students when you're looking at the heparin, it tells you here, bolus the patient with 80 units per kilogram body weight, start a drip at 18 units, and then answer the 2 questions below the heparin protocol. So that's important to know that you need to go below the heparin protocol and then answer these 2 questions. Bottom line, what you're looking to do is you're looking to convert units of bolus to milliliters of bolus, and then units per hour to milliliters per hour for the infusion rate. So let's work through that. So it looks like they already gave you the amount, unless that was Natalia's work, but 198 divided by 2.2 is 90. So it's even. It's a nice even number to work with, which is great. So let's work with that. And then let's show you how we can answer these questions. So I'm going to give myself some space to write. So as I did in the previous micrograms per kilograms per minute question, I always start with the patient's weight. You can start however you want, but that's how I always do it. I'm going to show this more of a traditional way, and then I'll show you the shortcut way. So it tells me to start a bolus at 80 units per kilogram. When I do this, I'm going to take 90 times 80. And I'm going to get 7,200 units. Now, if this is all I was looking for, then I'd be done with the question. Unfortunately, that's not what we're looking for. We're actually looking for milliliters. So I need a way to convert units to milliliters. So this is what I was mentioning before. Even without looking at anything else, I know that that's my next step, is that I'm looking for something that's going to help me convert units to milliliters. So that, again, could be something that helps you to decipher what's extraneous information and what is the important information. So what I need to look at is in step 2 of the protocol, it tells me the available. I have an IV of 25,000 units heparin in 250 milliliters, half normal saline. And then I have a bolus dose of 1,000 units per milliliter. I'm calculating a bolus dose. So that's the information I'm going to use. So I'm going to take 1 mil, 1,000 units, 7,200 divided by 1,000, and I'm going to get an answer of 7.2 milliliters. Is that what the key says?
Yes.
Good. Just want to make sure there's some consistency there. All right. So 7.2 milliliters. The shorthand way, because the heparin protocol is a standard, if you do a Google search for heparin protocol, you're going to see what is written up up on top there, where it's going to tell you start at 80 units per kilogram, then start at 18 units per kilogram per hour. And then the bolus dosage strength is going to be 200, or the bolus dosage strength is going to be 1,000 units per milliliter. And then your available heparin is going to be 25,000 per 250 ml. So that's standard. I've never seen it deviate from that. Always obviously double check your orders when it's given to you. But the shorthand way of doing this, if you ever just want to double check your answers real quick, you're going to take whatever the patient's weight is in kilograms. Okay, so that is the only thing that's really going to change. So if I'm doing a bolus, I'm taking my kilogram times my bolus, which is the 80, and then I'm dividing by 1,000. That will always give me my bolus for the heparin protocol. And that would be in ml. So if the patient weighs 72 kilograms, 72 times 80 divided by 1,000. If the patient weighs, 75 kilograms, 75 times 80 divided by 1,000. That would be the quick and dirty way, or quick and easy way of calculating what your bolus dose is. This is the more nuanced way of doing dimensional analysis, which just in case they change the numbers, but they haven't over the years, and I don't anticipate that. So that was for A. For B, same patient, same weight. This time it tells us to start an infusion at 18 units per kilogram per hour. We're getting rid of kilograms. 90 times 18 is 1,620. And this is units per hour. You've done this question a bunch of times whenever with your converting units per hour to for heparin, converting units per hour to milliliters per hour for insulin. So you've already seen this type of question. I need a way to convert units per hour to milliliters per hour. So before I even look for any of my information, I already know that this is what I'm looking for. I go back to the protocol. I look at my available. I know I'm not using the bolus because I'm only using bolus for bolus. 25,000 units, 250 milliliters, half normal saline. So those are the numbers I'm going to use. So 25,000 units, 250 milliliters. Now, I'll tell you right now, just for future reference, this number right here, or this 250 over 25,000, is the same thing as 1 over 100. So you'll hear me say that like in just a moment when I talk about the shorthand way of answering this this particular question. But you should get an answer of 16.2 milliliters per hour. And then the shortcut way for the infusion rate would be kilograms times 18 divided by 100 would give you the infusion rate of milliliters per hour. All right, so that was the big obnoxious heparin protocol. And then I gave you some shorthand ways to kind of, if you are looking at these, like how to answer these questions. But let me know if you have any other questions, anything from the previous 30-something questions you have here. Go ahead, Natalia.
I think it's a pretty simple question, but number 29, but can you show where you would mark the dose on the syringe. So I think it should be like 0.5. But also, what are the numbers above, like 4M, 8M, 12M?
Yeah, so I have to say, like, this, I don't know what those 4M, 8M, 12M is. They could mean molar. Because I don't think they mean milliliter. I don't know what those numbers are. And actually, it's not even clear that the 0.1, 0.2, 0.3 is milliliters either. But
Yes.
we have to assume that that's what that is. But I agree with you. Like, I'm not quite certain what we're looking at there. Because normally the syringe would be labeled with milliliters. So I just want to, I'm just going to make a note on that too. Okay. But yes, so if I'm marking this, you're exactly right. And that's what I think she just wants you to know is that you're be able to do is that you could mark at the 0.5, which it looks like it would be here. It doesn't say to, it just says mark the dose. Oh, well, she even tells you it's a 1 ml syringe. So at least you know that. So you have to assume that it's 1.0, that this side is the milliliter side. Right. And so this is for your TB test. So yeah, and draw your line better than I did. I kind of just passed a 0.5, but you get the idea. Sometimes they'll tell you, like at Boyce, they ask them to shade it in. So
I feel like it's pretty easy, but could you go over 19, please?
Sure. I'm going to tell you guys my perspective. They're all easy, right? But that's why it's good to like look it over. So don't downplay it and say like it's probably easy. Like just let's work through it, because that way we can kind of see. Now, I will say sometimes you'll see questions like this where it'll give you extra information. Since you're asking about that earlier, it might tell you like you have a 500 milliliter thing full of 240 milligrams of some medication, but then we're just calculating infusion rate. You don't even need to worry about the milligrams, because that doesn't tell you it doesn't tell you how to calculate the infusion rate. You just need to know volume and time. So 19, we're infusing at 120 milliliters per hour with a drop factor of 15. So this is another thing. Like, do I need to know the total volume to calculate a drop rate if I already know the flow rate? And the answer to that is I don't. I need to know the 120 milliliters per hour. I do not need to know how much is there. The only reason I would need to know the total is if it was, let's say it told me 500 milliliters and it was to infuse over 2 hours, then I would want to know, then I would use that information. But since I already have my flow rate listed here, I already have the 120 milliliters per hour. That's the information I need. Okay. So I'm going to take my flow rate, 120 milliliters per hour, and I'm going to multiply by my drop factor, which is 15 drops per milliliter. Now, the one thing, if you're just doing 120 times 15, you're doing that right. You just got to remember that you're in hours and that the question is asking you for a drop rate, which is drops per minute. So you need to remember to convert hours to minutes. So if you're doing it dimensional analysis wise, you just need to remember 1 hour, 60 minutes. I like to take this this first step here where I did 120 over an hour. I would put that as 120 over 60 times 15, and then I would come to the same answer. But 120 times 15 divided by 60, we're gonna get 30 milliliters or 30 drops per minute. Sorry. there's a button on my pen, and if I accidentally press it, it just starts continuing to write and I can't stop it. So, okay. And then as a reminder, if you get something like 27.8, drops per minute, you can't give somebody a decimal drop. So you would round to the nearest whole drop. So that might be 28 drops, or it might be 24 drops. Just make sure you're paying attention and realize that you cannot give somebody a partial drop. All right. While you guys are kind of thinking about any other questions, I just want to look through and see, because some of these things like this Demerol one is a different question. That's pretty straightforward.
Can we also look at the insulin question? I know there is always confusion how you would show it.
The
Like,
sliding scale?
The 23, question 23. No, when there are like two syringes, because the question asks what you draw first, but I think they want us to show the sort of the final, I don't know, like presentation of different kinds of insulin in a syringe.
You are correct. So let me pull up. There's a if in the OneDrive folder that I've shared, it's listed as mixing 2 types of insulin in 1 syringe. So let me show you that real quick, so I can show you where this all is coming from, just so that way you have a reference point. So in in the textbooks, this is essentially what they're asking you to label or to look at is, let's say you are to administer 30 units of Humulin N, 10 units regular, and then they want you to mark a syringe. First, you need to recall, and I know you all already know this, that you always administer regular, or you draw regular first, then you draw the second insulin type. They always say, I guess the acronym or the mnemonic is like clear before cloudy. But the main reason you're doing that is because that way you are making sure, because once you pull up the cloudy, everything becomes cloudy. And that's the thing. That's where I think everyone gets like hung up on this, is because like, well, there is no separation of regular from the non-regular when it comes to insulin. When we draw it up in the syringe, we've all seen it, because it doesn't exist in a vacuum. So anyways, this is how they want you to mark it. So I'll show you how I would mark that question. I just want you to see that this is from a textbook. So if you decide that this is not how you want to do it, I will tell you that the way I'm going to show you is an acceptable answer and what is correct. So on this question, it tells us that the patient is to receive 22 units of regular, 36 units of U100 NPH. You're going to choose A or B. You always choose in syringe B if it's this question, because it's the only one that is marked in units, and we measure insulin in units. So you can just ignore syringe A if it's always this image. It says to use 2 arrows to indicate, and then I'll show you what I would do to kind of circumvent the 2 arrows thing. But I always like to make notes on my test. If it's paper, solution amount to be drawn up first, I'm going to write 22 units regular first. I would just make sure that way I want to make sure that you're telling your instructor that you know which one goes first, and then that you can add, right? So 22 plus 36 is 58 units total, right? All right. So marking the syringe. I'm going to mark at 58. And I hope you guys know that these are in increments of 2. So here's my total. Okay. Where am I going to make my regular? Remember, regular is closest to the plunger side. Okay. So it's going to be 58 minus 22, which happens to be the same number for the NPH, which is 36. So I'm going to make another line here. And then I'm going to draw kind of like one of these. And then just indicate that this is regular. And then I'm going to indicate that this right here is my NPH. It's NPH, right? Yeah. So if I'm marking the syringe, this is how I'm marking it. Regular is between 36 and 58. So the 22 units of regular. And then the 36 units of NPH is between 0 and 36. Yeah, let's go ahead and let's look at number 30. Okay, so your shift is from 7 a.m. to 3 p.m. or 0700 to 1500. You make rounds at 7:30 and find an IV of dextrose 5%, half normal saline, 1 liter bag regulated on an electronic infusion pump at the ordered rate of 125 milliliters per hour, 500 milliliters remaining. The order specifies a continuous infusion. At what time should you anticipate hanging the next bag? All right. So you come in, you're making rounds at 7:30. So that means that's the time. So this initial thing just tells you your shift. The 7:30 tells us the time to start with. I actually like this question because I think this is a little bit more like realistic problem solving, letting you kind of, decipher. And also just remember, you didn't start rounds at 7. You started rounds at 7:30. Unless I'm reading into this incorrectly, you guys can correct me. But so the question is, how long will the infusion, when will the infusion run out and when should you replace it, right? So let's look at it. So the first thing I want to know is, how long is this going to run for? So the way I do this is I just always, for these types of questions, if I'm doing dimensional analysis, I write my total and then I convert milliliters to hours. I'm always converting stuff. I'm going to show you the easy way that I do this. Okay. And then that gives me, I think it's 4 hours. Okay. The easy way is I just take the 500 divided by 125. So I take my total divided by my infusion rate. That's how I do that if I'm doing it like quickly in my calculator. But 4 hours, as long as we get that. So when did it start? Or when did she check it? Or the nurse checked? The nurse checked at 7:30. So what's 4 hours from there? So plus 4 hours, right? So we're going to get 7, 8, 9, 10, 11. So 11:30 is when we would check infusion rate. Everyone okay with that?
Yeah.
Is this test going to be on paper or online?
I actually don't know the answer to that. My assumption is that it'll be a paper test, but I don't know.
I'm asking because, for example, if it's online and like, should I put 11:30 or 11:30 a.m.?
So notice what it says here, right? It says use military time. So military time, there's no AM or PM.
Okay.
Good question. All right, number 20. All right. So we have 180 milliliters. Packed red blood cells within 1 hour. Drop factor is 10. What is the drops per minute? So for this, now I'm gonna do this the way that I mentioned before, where there's I'm gonna, because I know I'm looking for drops per minute, I'm just gonna kind of shorthand this and simplify things so I don't have to worry about making the conversion, because I know that 1 hour is 60 minutes and I'm looking for minutes. Okay. And then times my drop factor. And then I'm going to get the same that I got before, 30 drops per minute.
I was just really overthinking that one, I guess.
That's okay. Yeah, sometimes when you see it and then you thinking that they have to do more conversions than is necessary, and then you just try it out and then it's like, oh, okay, that's pretty straightforward. So
Thank you.
you're welcome anytime. All right, we have a few minutes left here. Any other questions?
If they ask, for example, if an answer is like half a tablet or like 2.5, should we, like, can we still put like 0.5 or 2.5, or does it have to be like 1 second?
So this is, I'm just basing it off of what I saw here in the key. Looks like, she wrote 1.5, half. You might want to just write them both just to be on the safe side.
Because here it's both.
Mhm.
In the answer key.
Normally, at least the way that I've been told over the years is that you would write it as half, like 1/2 for half a tablet versus the 0.5. I don't know that it technically matters all that much, but if I don't think you're incorrect by putting both answers, like how she has it written here in the key.
I know we don't have a lot of time, but is there any way to make like number 11 a lot more easier? Because I like not like, but like for like setting it up wise.
Sure. So you mean like without all the long steps?
Yeah, because I do desired over half, but if I need to, I'll do that. But it just kind of overwhelms me.
Okay. So what I would say for that, for that, to make this, to simplify this, Kevin, is I would say make sure that you, first of all, ordered over half, unfortunately, will not work for this question. So there has to be another strategy. And And then, but what you can do is you don't have to do what I did. Like you don't have to do it one long drawn out thing. It's just that way you minimize the risk of missing a what's it called? Missing a rounding or making a rounding error, which is why a lot of times we just show it all straight out. But if I'm doing this, the way I've done this in the past is I would say, take the patient's weight. So like we have the 70 and I would multiply it by the 5. And then I would have 350. And then you just need to make sure you know the units that you're in. Okay. So, and then I would just do it in steps. Okay. Then I would say, okay, I can either convert to minutes to hours, or I can convert micrograms to milligrams. That's something, unfortunately, you just have to know that that's the next step. And so then I would do that next. I would say, okay, I'm going to convert, let's just keep it simple. I'm going to convert minutes to hours. And then I would find out, what does that equal? Once I have that written out, then I would find out, okay, I need to convert micrograms to milligrams. Now, if you're good at like just moving the decimal for that, that's perfect. You don't have to necessarily do the steps of micrograms to milligrams, but you still have to chop it up, either chop it up or do it as one long dimensional analysis. Or if you're like, I don't want to waste my time learning this, that'll be the one question that I miss. Like, that's okay too, because you can miss 2. But I think if you practice it enough times, a few times, you'll be able to get it. So that would be my advice, is just to practice how I showed you. The way I have it written here is how it would always be. It would be in that order. The only thing that you would decide to change is if you switched 60 minutes per hour and 1/1000, you can switch those two, however you'd like.
Okay, thank you. I think I'm just gonna chop it up because it's easier to chop it up, I think, because it's not as a longer problem.
Mm-hmm. Yeah, as long as you're getting the right answer, the 13.1 mil per hour, then you're doing it right. So just, practice or try it chopped up. If you're on later on today, Kevin, I'll do it chopped up. And then that way you can kind of see that we get to the same answer.
Okay, thank you.
You're welcome. All right. Well, that's it for now. Like I said, I'll be back on at 6:15 for 240, as well as on Tuesday from 2:30 to 3:30. If I don't hear from you before then, I wish you good luck on your test. And then, of course, if you can't come in the other times, just please, you can always email me too.
Thank you. Have a good one.
Yep. You're welcome.
Thank you very much.
Thank you. Yeah,
Good
you're
night.
welcome.